Hi friends, welcome back. Today we are going to solve one Amazon Facebook coding interview question. It's on Leetcode 155 MinStack. So as you can see from like dislike ratio, this is very likable problem and quite important problem also if you are preparing for any coding rounds of interviews. So make sure you watch this video until end so you will completely understand this problem. I am going to explain you the logic, Java implementation along with examples so you can completely understand the problem. We'll go through the problem statement, we'll understand this problem in today's session, and we'll also implement the problem. Before we start looking into the details of this problem, I want to mention that this channel is to help people in their coding and Java interviews. On this channel, you will find lots of helpful videos that can help you in your coding and Java interview preparation. For example, there are more than 400 different varieties of problems solved and explained on this channel. Those are essentially coding questions previously asked by big tech companies that includes Amazon, Apple, Microsoft, Yahoo, Netflix, Uber, Google, and many others. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, this channel can definitely help you in your preparation. So please subscribe to this channel now. Also, whenever we solve any important coding problems, we create videos on this channel so that we can discuss approaches, logics, and solutions to solve those problems so that others can also understand how to solve those problems using Java programming, data structures, and algorithms. So make sure you click on the bell notification icon so you will get immediate notification as soon as we create new postings on this channel. So let us start this important problem, MinStack. So design a stack that supports push, pop, top and retrieving the minimum element in constant time, right? So constant time means O1, right? So that is important. Implement the MinStack class. So MinStack is the initialization of stack object, and push is we have to push the element into the stack, that's fine, and pop removes the element from the top of the stack, that is fine. Top gets the top element of the stack, that's fine, and getMin retrieves the minimum element in the stack. So this is something new that we are seeing, right, compared to other stack operations. We already know other stack operations, push, pop, but getMin is basically we always want to retrieve the minimum element that is in this stack actually present, right? So that is a new method. So this is the example. We'll take a look at constant. So value can be between minus 2 raised to 31 and 2 raised to 31 minus 1 inclusive, right? So that value that they are going to give us to push, that can be in this range, and the pop, top, getMin operations will always be called on non-empty stacks, so we don't have to worry about whether the stack is empty or not right here, because they have already told us that. And at most 3 into 10 raised to 4 calls will be made to push, pop, top and getMin methods. So 10 raised to 4 is basically 10,000 into 3, so 30,000 calls may be made, right, while they are testing our solution. So we have to implement the solution in an efficient way, right? Otherwise it will not pass the test cases. So to understand this problem in details, we'll just go to the whiteboard where I can explain you like more details about what the problem is. I created one example for us here so that we can discuss the problem. So let's first understand with this example what the problem means, right? And then we'll implement, I'll explain you the logic how we can implement this problem, right? So MinStack means basically they are, in this case they have given 1 2 3 4 5 push operations. So first 5 push operations are there, so we are going to push some value into the stack, right? So I hope everyone is familiar with the stack concept, stack. So how stack works? So if you don't know already, right, if you are a new Java developer or if you don't know stack, so what happens in the stack is whatever you push into the stack, so basically it is last in first out data structure, right? Last in first out. So how does it work? So let's just discuss in general, right? So I push, let's say 10 I push here, right? Then 20 I push, then 30 I push, on 40 I push on the stack, right? So whenever I am removing elements, I'll get whatever I last pushed first, right? So I pushed last 40. So when I'm removing, I'll get 40 first from this stack. When I am again removing, I will get 30. When I am again removing, I'll get 20, and when I'm again removing, I'll get 10, right? So basically, last in, first out data structure, right? Stack is like this basically, correct? So it is something you can imagine. If you are a new developer, then it is something like a container, right? Let's say this is a container and you are putting some plates here, right? One plate is there, then second plate, then third plate and fourth plate, right? These are the plates. So once you put plates like this, then you cannot take this plate first, right? You have to first take this plate, then you will take this plate out, then you will remove this plate, and then you will reach to this step plate, and you can remove this plate, right? So this is how the stack works basically, right? So now you are clear with how the stack works. So now let's go to our problem now, right? So let's they have given us first we will understand what the problem is, right? Then it will be clear to you. So we are given 5 push operations. What values are we pushing? So 4, 2, 1, 10 and 40. Sorry, 10 and 20, right? So let's push these values. So 4 we push first, then we push 2, right? Then we pushed 1, we push 10 and we push 20 after that, right? So this is what values we have pushed, right? So now when we are actually calling a getMin method, right? So we should get the minimum value that we have into this stack available, right? So what is the minimum value available? 1, right? So we should get 1. So this is what we have to return here, right? And when we are pop means we are removing the top element from the stack. So this one we will remove. So 20 will be gone basically, right, from the stack. Now when we call the top method, it should return us the top element from the stack. So 10 it should return. So 10 it is returning. It just returns 10, but it does not remove it basically, right? It's just returning that value, but we are not removing that 10, right? And when we again call getMin, again we will, in these 4 values that are available now into this stack, what is the minimum value? 1. So we want to return 1, correct? So this is what the problem is. So with this example now it is clear to you what the problem MinStack is, right? So now we will understand how we can implement this problem, right? So let me just remove this. So what we will do to implement this problem is, again this is a stack and we will again use a stack actually to implement. Also we will use one stack, right? And how will our stack look like? Stack will actually hold 2 elements. Stack will hold actually 2 elements, and how we will hold it? We will create a stack of integer array, right? We will create an integer array. So every element in the stack is an integer array. So how many elements will it hold in that integer array? It will hold 2 elements, correct? It will hold 2 elements. So what are those 2 elements? The first element will be the number that we are pushing, right? For example, if we are pushing 4, right? If we are pushing 4, then the stack will hold like this, right? 4 it will hold, and the number that we pushed, and it will hold the minimum number that we have seen so far, right? So what is the minimum number we have seen so far? 4. So this is what the stack will hold. That's why we will use integer array here, correct? So now let's just go through this example, and I will show you how we will just modify now our stack, right? So now we are actually, let's say we are pushing here 4, we are pushing, right? So how it will be added into the stack? 4 comma 4, right? 4 comma 4 it will add. 4 comma 4. Now what is this? First is the value and second is the minimum value that we have seen so far, right? So you got it, right? So this is the minimum value we have seen so far is 4. Now when we add next value 2, right? Next value we are adding is 2 into the stack. So how it will look like? 2 comma 2, 2 comma 2, right? Why it is 2 comma 2? Because as of now we have seen the minimum value 2, right? So it will just hold 2 here, right? After that when we add 1, it will create 1 comma 1. So 1 we have added, and the minimum value we have seen so far is 1, right? Is 1. Now when we add 10, right? When we add 10, we will add 10 and 1 here, right, in this array. Why 1? Because in these values we have seen minimum value 1 so far, right? In these 4 numbers we have seen 1 so far is the minimum value, correct? Then we will add 20, we will push 20 onto this stack. Now 20 comma 1, right? That this is what we will push. And why? So what does it mean? That 20 is the value that we are pushing and 1 is the minimum value we have seen so far, right? So that's what we have pushed into the stack. So if I just want to show you how it will look like internally, so this is a sample, right? That this is how the values will look internally if I want to show you that, right? So this is what same values we are pushing 4, 2, 1, 10, 20, right? So when you push 4, you will see minimum as 4 here. When you push 2, minimum value is 2. When you push 1, minimum value is 1. So when you push 10, minimum value is 1 you have seen so far. When you push 20, minimum value you have seen is 1, right? So this is how internally our stack will look like basically, correct? If I show you. So this first element is the actual number, right? That actual value that we are pushing. For example, 20. So 20 is the value that we are pushing actually, right? 10 is the value that we are pushing here, correct? So that's what it means. And this first number 1 element is the minimum value we have seen so far. Here also this is the minimum value we have seen so far, right? So now you got the idea how the stack will how we will push the values here, right? And whenever we are pushing, we will keep always track of what is the minimum value we have pushed, we have seen so far, right? So more will be clear when I show you the code, but now you got the idea. So now let's say if I want to call the getMin method, right? GetMin method. So I will already know using one variable what is the minimum value we have seen, correct, in these values. So 1 is the minimum value. So I can just return 1 there, right, as the answer in the getMin method, right? And when I pop out, one thing actually is I wanted to say is about the getMin method, right? How we will implement getMin method? We will go always onto the top of the stack. We will go here, top of the stack, and we will read this minimum value, basically, correct? That's what getMin method will do. You got it, right? So now, for example, now if let's say I remove all these 3 elements from the stack, right? 1, 2, 3. So now I don't have these 3 elements. Let's just assume for a sake of discussion, when I call getMin method, it will go here and then it will read this value, right? This is the minimum value it will give us, 2, because we are now only talking about these 2 numbers that we have pushed, right? These 3 numbers we have already removed from the stack. So it should tell us what is the minimum values between these 2 numbers, correct? So that is why we will always go to the top of the stack, and we will read this minimum value here, right? That's why we always store that minimum value along with the value, correct? So now you got the idea how the getMin will work, right? Pop method is very simple. Pop method just removes the top element, right? So we just remove this top element from the stack, right? Top element will remove it, and top method actually will return this number. Actually it will just return this 20 number when we are calling it, right? Let's say we are calling top on this stack. Now it should give us this 20 as the top, correct? We just return, we don't remove it, basically. That is the difference now, right? Now whenever we call getMin method, we will always go to the top of the stack and we will read this second value. This second means this value, right? Second value that gives us the minimum value that is available into the stack, correct? So I hope with this detailed explanation you got the logic clear now, how the MinStack we will implement. So that's why we will always hold 2 values in that every element. One is the actual value and one is the minimum value we have seen so far, correct? So it is easy now to you to implementation. If I show you, it will be easy for you to grasp that implementation. So we will create a stack, but now stack will be holding integer array, right? Integer array, because we want to hold 2 values here in this array, correct? So now I think I'll just go ahead and I'll show you the Java code now. Then it will be even more clear to you how the implementation will work. So let's go to the code. So this is our implementation. So first we will create a stack. As I said, it is an integer array, right? It will hold integer array, and we'll just call it as stack, right? So MinStack is the constructor. So here we will actually instantiate the stack, right? So we'll just say new stack. So it will create the stack, and then let's take a look at the push method, right? So we will get a value that we want to push onto the stack. So what we do is we will actually just read the current minimum value as a null value, right? Then we will do, if the current stack size is 0, it means that nothing is there into the stack, right? Like for example, first time nothing is there, then current min value will become this value, right? Because that is the first value we are seeing, because nothing is there into the stack, right? So we'll just initialize the current min as the this value, correct? Now if something is there onto the stack, then what we will do, we will always look at the top min value, right? This peak means we are looking at the top value, and we are looking one index 1 is basically the min value, because we always keep min value at index 1. Actual value we will keep at index 0, and the minimum value we have seen so far we will keep it at index 1, correct? So that's what we will do is current minimum is equal to, read it from the top, the minimum value, and this current value that we are seeing, whatever is the minimum will become the current minimum, correct? So for example, now let's say, um, let me just remove these colors, lots of colors are there. uh, so let's say what I mean to say is, um, if we are here, right, if we are here, as of now we have seen this 2 is our minimum value, correct? 2 is minimum value. So when we are inserting 1, we will compare this 1 and 2, whatever is the minimum we will take, right? Between 1 and 2, 1 is minimum, so we will take 1 here, correct? So that's what we are doing, right? So that's what we are doing here. So we are always having the current minimum here, and then we will push into the stack the value here and the current minimum. So this current minimum, we always will get that current minimum that we have seen so far, basically, correct? So this is how the stack will push into the stack. This is the value and current minimum, two elements we push, correct, into the stack. And that is why our stack is holding integer array, right? So what does the pop do? Pop will just remove it from the top of the stack. So stack dot pop, right? We will implement like this pop method, and top will give us the top number, right? Top value it gives. So how it will give us? Stack dot pick 0, right? Because 0 is the value, right? So 0 will just return here as a top. So pick method actually returns the value, it does not remove it, it just returns, right? And then getMin, actually we will again pick it, means we are actually looking at the top of the stack, but we are looking at the first index, right? First index holds the minimum value, right? So that's what getMin, how we will implement getMin method, right? So this is pretty clear to you now. This is a constant, like as they said, let me show you. So this one is a constant time, basically, correct? Constant time implementation. So now we can just and the memory it will hold, we will need this stack to hold the elements here, right? So if we have, let's say, n different numbers, then in order of n will be the space complexity for this solution. So I'll just show you couple of examples we can test. So this is the same example I shown you, right, just now. So this is the one that we saw, right? So we can just test this example. So we are actually pushing 4 to 1 10 20, and then we will call min. So min will give us 1 here, right? So min is giving us 1 here, and then we will remove it from top. So this top will be gone, basically, correct? Then we will, if we call top, then we will get 10, right? So we will get 10. 10 is on the top, and again if we call getMin, again we will get 1 here, right? So let's just execute this test case, make sure this approach works. So we are getting correct answers, as you can see from the output. So we can test with their test cases. So this is their test case, right? The first example. Let me make sure it also works. So we are getting correct answer for their test case as well. So we can just go ahead and submit our code to the Leetcode now for MinStack. So this is one of the popular Amazon Facebook coding interview questions. So make sure you practice this question. So our solution got accepted by Leetcode. Let's try to resubmit it. Sometimes the numbers are not correct. So now it is showing 68%, right? So now performance is 68% faster than other submissions which are done online, and the memory usage is 59% better than other submissions, which is a pretty good solution for this problem. MinStack, Facebook, Amazon coding questions also asked by many other companies as well. So I hope you understood this problem clearly now with these examples that I shown you with the detailed explanation. And this is the internals, how our stack will look like, right? So it always hold two elements, as you can see, right? 0 1 0 1 always hold two elements, and always it holds the value and the minimum value, like, right, 10 is the value and 1 is the minimum value, right? 20 is the value, 1 is the minimum value we have seen so far, correct? So if you are new to this channel, there is a dedicated playlist on this channel for Leetcode problems. You will find more than 250 different varieties of Leetcode problems solved and explained. All the problems come with Java solutions code, where the Java code is shared through GitHub repository. Links are always shared through the video description, where you can check out the Java code, play with the Java code with different test cases for your better understanding. If you like this video, if you find this video helpful, and if you like the way the video is created with this whiteboarding session, examples and Java code, then please give it a thumbs up to the video, give it a like to the video, subscribe to the channel. Your subscription is very important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. Some people find it difficult to solve different varieties of coding problems. Through this channel, we would like to help them by showing and demonstrating them how different problems can be solved using different data structures, algorithmic techniques, and Java programming. So they can also learn from this video more about problem solving using Java and data structures. So if you like this video, give it a like, share it as much as you can, so more people will come to know about the channel. They will also watch these videos and learn from these videos. They will also understand how we can solve different problems using different data structures, and also get help in their coding interview preparation process. To become more and more confident in your coding rounds of interviews, try to practice different varieties of problems. The important varieties of problems you should try is BFS, DFS, graph problems, matrix problems, binary search tree related coding questions related to linked list, strings, optimization problems using priority queues, dynamic programming problems, as well as lots of logical problems, right? So if you practice those problems, if you go through these videos on this channel, you will get like a really good preparation for your coding and Java interviews. Whenever we solve any important coding problems, we create videos on this channel so that we can explain our logic and approaches to others, so they can also learn from these videos more about Java programming, data structures, algorithm, and computer science techniques to solve different varieties of problems. So make sure you click on the bell notification icon, so you will get immediate notifications for all our new upcoming videos. Keep coding, keep learning, keep practicing, and thanks for watching this video.